Hey all, it's Andrew Couch here, and in this Tidy Tuesday video, we're not going to be looking at this week's dataset. Instead, we're going to focus more on the TidyModels package and extend it towards the post-modeling process, specifically in determining the correct model. And I got this inspiration from a week ago because, just to give a live update, I recently accepted a data scientist position for a logistics company, and during the interview process, they actually gave me a assessment where I had to create a model for them. And one of the problems that I faced while creating the models was I had two models that had very similar performance metrics, specifically in the AUC scores. So I was trying to decide, which model should I be choosing for the final submission. So I figured I could kind of go over my workflow and thought process when determining the optimal model when these models are essentially tied. So for our data set, we're actually going to use the telco customer churn data set, where churn means basically customers who left within the last month. So we're basically trying to predict whether a customer will leave our company. So we're going to load up a tidy an R markdown file. I'll call this Tidy Tuesday model eval. Erase all this stuff. Load in the tidyverse, TidyModels, and then I'll just read in our CSV, which is called customer churn.csv. Okay. Just let's look at the summary. So just look at all the features, right? So we have a customer ID, gender, senior citizen. So these things, we look at senior citizen, it's just zeros and ones, I'm assuming. Partner, and then we have our churn right there. So when I'm looking at this, one thing we're going to have to remove is customer ID. Our customer ID could be useful if we wanted to do, say, a bunch of like feature engineering with that customer. We had other data, but we're gonna remove customer ID. We're gonna have to do some data cleaning because I think some of them are characters, some of them are ones and zeros, etc. So there's gonna be some data cleaning that'll be pretty simple. Let's see what else. Additionally, we have some NAs and total charges. So I just want to look at the amount of rows. So we have 7,000 rows. So what I'm going to do is actually drop the missing values. So drop NA. Okay, so I'm going to say look at summary of the data set, and then remove the 9 missing values. Cool. So since we have all this stuff, we should probably start cleaning it. So what I'm going to do is I'm just gonna say mutate all, and I'm gonna say all these values should be as dot factor. Okay. However, what we do know is that tenure should not be a factor. What else should not be? And monthly charges shouldn't be a factor. And total charges. So we can just convert those. So mutate tenure equals as dot numeric tenure. Was it monthly charges equals as dot numeric monthly charges, and then total charges is equal as dot numeric total charges. Great. Just gonna look at the summary just to make sure we're not doing anything wrong. So gender, these are factors. Tenure is numeric. Monthly charges, total charges. Okay, sweet. So I think that's all the data cleaning. Yeah, so I'm gonna just assign that to our original data frame. They convert features to relevant data types. Okay. So now we have that. We can actually start creating our train and test splits. I just wanted to say that we're going to focus more on the post modeling process over the actual feature engineering, data cleaning, stuff like that. I think I've made a decent amount of videos on that stuff beforehand, so we're just going to focus on one specific thing. So I'm going to go a little bit faster on this modeling. So I'm going to create a recipe called tidy recipe or tidy rack. I'm going to use all the features. First, I'm going to do step remove, and that's going to be, what's it called again? So customer ID. So we'll say like customer ID, step normalize, all numeric. And then I'll do step dummy, all nominal minus all outcomes. Oops. Oh, oops. Wow, actually, let me create the training test sets first. Training test set, training test sets. So create training test sets, and then I'll do, what is it, set.seed equals 42. Tidy split, initial split, data frame. We're gonna do a 80-20 split, so proportion equals 80. I'm also gonna stratify based off of churn. So that way, each train test set will have the same proportion of positive and negative churns. So we'll create our train data. Training tidy split. And I'll do was it vfold dv. Yep. Got that. So we create our training test sets. I created also a 10-fold cross validation. I'm gonna prep my recipe just to see what it's doing. So let's see here. Variables removed, customer ID, center and scaling for 10-year monthly charges, total charge, create dummy variables, etc. Cool. So now let's just create our models. What I'm going to do is I'm going to create 3 models, which I think are probably the most common models you'll see. One of the first ways to actually create and determine whether a model is performing well is create a baseline model. And with the baseline model, I think the best baselines are usually like linear models. So if you're doing a classification model, use a logistic regression. If you're doing a regression problem, use linear regression. So I'm going to do logistic reg, set mode, set engine, PLM. You may also notice that in my past videos, I usually put the parameters that I want to tune. In this case, for this video, I'm not going to tune any of the parameters. But you can definitely, I think generally you'll be tuning parameters. So just for, just to make this video a little bit faster and we don't have to kind of worry about the tuning, we'll just kind of leave them as their default parameters, which TidyModels does a pretty good job on. All right, so once we have our baseline logistic regression, I'm going to make 2 models, a random forest and an XGBoost model. I think those are kind of like the default predictive modeling models that people use, and it's a pretty common model. So we're going to do that. Oops. Okay, so now we have our 3 models. What I'm actually going to do is I'm just going to use our 10-fold cross-validation using our default parameters and just fit them to those 10-folds. What this will do is kind of give us some of the metrics that we want to look at over 10 folds or 10 train and test sets. So it kind of give us a reasonable look at how well our models are doing and our model stability. So I'm going to say fit resamples, logistic res, fit resamples, logistic, oops, it's called baseline model. We're going to give it our recipe, and we're going to also give it our tidy k folds. Okay, and then we'll say random forest res. Random forest model, tidy rec, tidy k folds. And then we'll do finally our XGBoost model. We'll say fit resamples, actually boost model, TidyRec, TidyK bolts. Okay, so I'm gonna fit these 3 models. Okay, and this will probably take a few minutes. So I'm gonna kind of go over why we're doing this first. So my number one thing that we should probably do for determining the optimal model is to evaluate it based off their baseline model. So that's why we created the logistic regression model. And basically, if our random forest or XGBoost model does not perform the same, with the same predictive power as our baseline model, we can pretty much choose the simpler model or our baseline model. So if we're using, say, compared an XGBoost model compared to a Mars model versus a baseline model, we would definitely look at the baseline model first. However, we would also want to kind of evaluate how complicated a model is. So generally, XGBoost and random forest models are more complicated than, say, a Mars model or a general GLM model. So if all else is equal, you should choose the simpler model. Oops, what did I do? Tidy. So we're almost done with our fit. So I'm just gonna do that. And if we just kind of look at our logistic, res, we can see our results. What I'm actually gonna do is create a list, put these fit resample results into a tibble. So what I'll do is tibble model equals list logistic res random forest res actually boost res. So we have a list of the resample results. I'm also going to create a model name just for clarity. So logistic random forest actually boost. And you might be wondering, why didn't I just put these models into a tibble and then map this function of fit resamples? Because I'm essentially just copy and pasting this 3 times. I actually tried it a few days ago and I kept on running into errors. I'm not sure if it's just because with fit resamples, it's doing something in the backend that confuses the mapping function, but it just wouldn't work for what I was doing. Maybe I was just typing in the code wrong, but it's definitely an option. I just couldn't get it to work when I was working through it. So we're just going to do this model res. And what we really want to do with our model res is I'm just going to use the baseline model as logistic res as an example. So what we want to do is basically, is select the fold and then the metrics. And then when we want to unnest the metrics. So that way we can figure out all of our metrics for each fold. And we want to do that to all of the models. So what we can do is basically a mapping function. So we can say map collect metrics, give it a function. I always like to give it what I'm actually going to put it input into. So like the input, right? I like to name the input what I have as my column name. So I'm just going to say model. And with the model, I'm going to say select id.metrics and then unnest it. So not a complicated function. You could definitely put it into the map as is, but it looks a little bit cleaner. Okay, so we have our model res. What I'm going to do is mutate res is equal to map model map collect metrics. And now we have our metrics. I'm also going to select the model name and the res, and then I'm going to unnest res. So now we have all of our models key metrics, so accuracy and ROC and ROC AOC for every fold, which means we have about 60 different rows or 30 models that we can evaluate from each fold. Okay, so I'm actually going to put this into that. Okay, so I'm going to say create a table model results, create a helper function for collecting the metrics, and then apply a helper function and extract the metrics. So then what we're going to do is go to model res, and we do a simple ggplot. So we'll just, what we're going to do is just ggplot AES x equals model name y equals dot estimate. And I just want to see a box plot. I'll fast wrap it by the dot metric scales is equal to free y. Dot estimate. Okay. So what we can see here is that basically our logistic regression model is beating most the random forest and XGBoost model. From like the median, so 50% of the logistic regressions models were beating the random forest's 50% or whatever. Okay. So this is something where I would definitely lean towards the logistic regression model. However, we can see there is some overlap. So although the logistic regression has definitely a tighter quartile range that's higher up, there are times when, you know, random forest and XGBoost are above the logistic regression model. So there's some overlap between these two, between the three models. Additionally, with the ROC AOC, we can see that yes, the logistic regression model still has a higher ROC/AOC score. However, XGBoost has more variability. And this is kind of a great example where if you use the first rule that I was talking about, I was just selecting the simpler model, then we could just do logistic regression and call it a day right there. But we're not sure yet, because on one hand, logistic regression, the final logistic regression model could just underperform these two models. And also intuitively, since we didn't really tune the random forest and XGBoost models, they're not going to perform as well as a logistic regression model, which basically has no tuning parameters. So I wouldn't say this should always happen where logistic regression will always beat random forest and XGBoost, just because we probably didn't tune it. And it seems that these random forest and XGBoost models needed to be tuned to the dataset. So since we have just this baseline kind of summary statistics of our model metrics, let's look at the model metrics through each fold. So we have our model res. What we can do is just create a ggplot. Model name y equals dot estimate. In this case, we're going to say the color is equal to the ID or the actual fold. And then we'll do a geom line plus facet wrap scales is equal to free y. Oops, and then I need to add a group aesthetic, which is the ID. Okay, so what we can see here is that there is some variability in the folds. Right, so for logistic regression, we can see that fold 10 has a very high accuracy compared to fold 9, by 0.78 to 0.83 probably, which is a decent amount of variability. We can also see that let's see here, that there are some times when, like for the folds, like random forest will have a bit higher accuracy than logistic regression, but then on a different fold, say for example fold 10, logistic regression has a higher accuracy than random forest. So you can see how they're basically changing, right? They're changing in what's the better score, which means that I would definitely be a little bit more critical or a little bit more skeptical about whether I believe logistic regression is better than random forest, etc. With ROC AOC, it seems a little bit more consistent, where in general, like logistic regression will be beating the random forest model. However, the logistic regression XGBoost seem to be a little bit more similar, and they might be varying a little bit. Finally, let's kind of look at a little bit more. Let's look at this metric in a more refined area. So let's look at the density of it. We'll do a ggplot estimate y was it color equals model name, fill equals model name. Okay. So what we can see here is that basically the logistic regression model definitely seems to be outperforming these the other models, but we can still see that we can't be sure that the logistic regression model is the superior model. One thing that I would say is when you're trying to evaluate models, it's nice to have a secondary metric. So on one hand, since our data set I think is relatively even. So if we look at our DF and it's a count turn. Oh, so it isn't very. So this is something where we can see that, okay, since our data set isn't as even as we thought, because I didn't really look at it, we can see that accuracy is not our best metric that we should be looking at. In fact, what we should really be looking at is ROC AOC, which is kind of nice because if we see that our classes are a little bit imbalanced, we should be using ROC AOC scores as it's more suited for an imbalanced data set. However, we always still have accuracy, and we can kind of use that as our secondary metric. So if we look at our model results, and we just do like a group by model name and then dot metric summarize. Oh, like mean equals mean dot estimate. So if we look at this, we can see that, okay, our logistic regression definitely has a higher ROC AOC score, and it's essentially tied with our XGBoost model, who has a similar ROC AOC score. We can kind of use our secondary metric, which is accuracy, as a tie-breaking score. So in general, our logistic regression outperforms both random forest and XGBoost in the ROC AOC score. However, logistic regression also beats the other models in accuracy. So that could also be another reason why we would choose the logistic regression model, because it beats all the other models with our primary metric, which is ROC, and it also beats our other models with our secondary metric. But we can also do one more step, which is to use TidyPosterior, which uses the resampled or the 10 folds to basically analyze the distributions of our metrics and to estimate how certain we can be that our model is better than the other models, which seems pretty useful in this case. So what we're going to do is we're going to have to convert it to a kind of like a traditional format. So what I'm going to do is I'm going to select the model name, ID. Oops, actually, what I'll do is first is I'll filter dot metric is equal to ROC AOC, because since our data set is imbalanced, I'm going to just switch over to our primary metric, which is ROC AOC. We're going to filter that. We're going to select the model name, ID, and dot estimate. Oops, spelled that estimate wrong. Dot estimate. And then what we're going to do is we're going to do a pivot wider. Names from is equal to model name values from equals dot estimate. Okay, so now we basically have 10 rows where each row represents a fold from our k-fold cross validation and our ROC score for all the models. It's pretty useful. So what I'll call this is, we'll say model POS. And now what we're going to do is load in the TidyPosterior package. So TidyPosterior. And what I'm going to create is I'll say ROC AOC model. And what I'm going to run is the perf mod, which basically does, it basically analyzes the differences between our ROC AOC scores between the models with the folds. I'll give it a model underscore pause. I'll set the seed to 42. And now you can see it using stan to basically randomly sample and sample the data set and evaluate how certain we can be that our logistic regression model is superior to the other models. Oops. So we can kind of look at our, was it ROC, AOC, AOC model. Luckily, since it's part of the TidyModels, we can just do tidy. And then we can have our posterior distributions, which is pretty useful. We can also do our ROC AOC model, tidy it, and give it a ggplot. And it'll give us the actual like violin plots of the distribution. So we can see how the variance between the fold is pretty even between the models. We can also, when we do the AS, X equals model, Y equals the statistic plus GM point. That way I have points on there just to see. And lastly, what we really want to look at is the contrast models function. So if we do contrast models and give it our ROC AOC model, we can see how we can look at this and say, okay, so comparing logistic to random forest, logistic versus random forest, the difference is 0.005. Okay. So this can give us kind of the idea of what we want to look at. Luckily, we also have, since we have a ggplot function for it. So if we do contrast models, ROC AOC model, and just do a ggplot, it'll give us essentially like a comparison or a pairwise comparison between the models. So what we can look at is how much better is our logistic regression's AOC score, and what's the posterior probability of it. We can see it's above 0, so we have some type of certainty that our logistic regression is better than the random forest model. As opposed to our logistic regression and our XGBoost model, we can see that there's some overlap between 0.0, which means that I wouldn't be as certain that our logistic regression is better than our XGBoost model. However, since our logistic regression model is the simpler model, I would definitely say that we should go with this logistic regression model given our set of tuning parameters and our data set. So essentially, if our random forest and our XGBoost model, if we want to compare these two, we can see that, okay, our random forest model is definitely has, you know, a slight decrease in the difference between the ROC AOC scores, which basically means that we can be a little certain that our XGBoost model is a little bit better than random forest. However, there is a little bit of overlap between the 0, which means that it may just be a fluke on the differences. So the TidyPosterior package sounds pretty complicated, especially when you see that it uses like stan. I think it uses like rstan arm. But in reality, it doesn't really come with a lot of functions. So if we look up the TidyPosterior, it only comes with basically perf mod, tidy, and some random helper things. So it basically comes with contrast models, perf mod, and tidy. So the perf mod is the main thing which creates the Bayesian model to analyze it. There's a lot of different things you can do with it. For example, if you look at our perf mod, you can see, okay, first of all, just to go back on this, is we can see that there's not a lot of functions. It's basically perf mod and contrast models. But with our perf mod, there are things that we can add into it. So we can add some transformations, which is definitely useful if we have a certain metric that might be needing some type of transformation. We can also do like heterovariance. So by default it says false, which I believe it means it doesn't use a like random intercept. Let's see here. So that might be useful. So if you want to turn it back to true, um, that might work too. But in general, just leaving it as is with no set, just like giving it with the data frame and then setting the seed, it'll just assume, was it a random distribution, which will be useful for just analyzing basically most of the models that you'll be looking at. So by default, a generalized linear model with Gaussian error. So I know this is a pretty simple video. We basically only went over one function, but this is actually a pretty useful thing. And hopefully you might have an interview where you need to do this, and it'll be pretty useful. So I'll see you guys next week, and tidy on.